One of the tremendous benefits of BIM is the reduction of waste, and it's usually waste as data or information flows through the project lifecycle. Here's an example of the traditional 2D delivery method. Collaboration hopefully occurs during design using 2D drawings. From those 2D drawings, bills of material, drawings, everything is developed to form the construction tender package. When that design package is transferred over to construction, new packages are built for as-built drawings or work packages, and then phasing scheduling is done based on interpretation of 2D drawings, and verification of any bills of or quantities of materials is done. Upon completion of construction, those 2D as-built drawings are passed over to operations, from which those as-built drawings are used to identify the current instance of the project as it stands, as well as to develop linkages to spare parts maintenance schedules, asset registers, etc. The critical thing, though, is everything that's developed from these 2D packages are developed in isolation. They relate to each other, but there's no physical or strong relationship between. They're isolated islands of information that have the potential of getting lost, getting wasted, etc. So to create a greater degree of efficiency, BIM actually has everything centralized, which is what we'll discuss next. Instead of the 2D process, when using a building information model, you have everything centralized in a collaborative model that's used during design, facilitating design coordination. From that model, all of the bubbles around that diagram can occur, from virtual walkthroughs, material schedules, bills of quantities, 2D layout drawings, clash and model analysis, and links to various other project documentation. The critical thing is you have one central house that stores all of the information and feeds it to the output. Therefore, you have a single source of truth, no data duplication, no data loss, and thus no waste. Upon completion of design, you have a robust model that can then be transferred over to construction. Now, it's critical to note that in a design, build, operate project, we're transferring it internal within CH2M Hill. In a design, bid, build, there are liability issues around the transfer of the model, but conceptually it's that same concept. The model is robust in design. In order to make the project most efficient for our clients, the transfer of the model to construction is optimal. During construction, that same model is now taken and augmented to become a construction model. So for example, in the design model, a concrete slab may be modeled as one piece. In a construction model, it may need to be modeled as 10 pieces. So they'll break that up as per the pours once they work out the work schedule. So from the model, they analyze it, they phase the model so they can understand how they're going to construct it, and then the model starts to become a construction model, which can then be broken off into work packages and given to the sub-trades. Once the information is collected and received, they can start to build the as-built information. So for example, if there's a pump in the design model, the pump may be placed in the model based on 1 to 3 possible specified manufacturers. Once the pump is procured, this model can then be updated with the actual information, the as-built information for the pump, and that's inserted into the model and then passed off to operations. This same process occurs, in theory, for every single building component that exists within the model, and thus, when the model goes to operation, it's rich with as-built information. During operations, we now have a robust as-built model, 100% representing the physical built form. So from that model, operators can create simulations with respect to security, safety, and training, and also attach maintenance information to the model based on the components, spare parts list, instructions. They can create a linkage to their local asset register, so that however they're monitoring their assets, they can have a direct linkage to the virtual BIM model to understand where those assets reside within the facility. So throughout operations, as components live and die, they need to be replaced. There need to be schedules placed on the replacement. All of that information can be attached to the model or linked to the model so that there's a single point of entry to understand what's happening to each of these components. You can drive through the model, select a pump, select a door, select a valve, and understand what's been done to it, either directly from within the model or through a series of linkages to other sources within the operation infrastructure. Beyond operation, you now have a model and a database robust with information pertaining to the components within the built space. Several times we're faced with projects where building reuse is critical. We would now have not only an as-built model of the constructed form, but a database within that model pertaining to all of the components that are housed within the building. If we wanted to reuse or sell pumps, valves, etc., we understand what's been done to these components, so where these components are, how much these components weigh, how these components could be recycled, where they may be used, so that we can decommission a building, reuse a building, and get it ready to get the information ready to be existing information for a new collaborative design process. So it goes through that cycle, and that cycle may last 15-20 years, but the critical thing is that model, which started in design and went through construction and operation, is now ready to be reused again, as the building that was once new is now an old existing building ready to be made new all over again.